In this video, we'll be using the online mapping tools to determine the seismic design loads for a hypothetical building location. We'll be using two tools, seismicdesignmaps.org and ATC hazards. They both give the same information, but this way you'll have an idea of the options that are available to you. Let's start with the seismic design maps. The hypothetical site that we'll be looking at will be student housing at Cal State LA. I've already zoomed the map in to close to that location, but I need to zoom it in a little bit more, so I'll adjust the map and I'll bring the cursor in roughly to the site where we're being designed. You can see that the latitude and longitude down here adjust automatically. We're using ASCE 716, risk category 2, and for the time being we'll choose site class D, which is the default selection. Everything is already populated, so we hit go, and we can now scroll down to see the results. You'll notice that we're given the values of S1 and S sub S. These are the parameters for the ground motion at bedrock. SMS and SM1, these are the parameters for the ground motion at the site. And SD1 and SDS, which are the parameters for the design spectrum for the building. You'll notice that SM1 and SD1 are given as null. They refer us to section 11.4.8. And the reason for this is that there are additional considerations in the code that we need to take into account. So we wouldn't be able to determine these values straight from this online tool. For this reason in class, I'll typically assume that we have sufficient geotechnical information to justify site class C. I'll clarify that this is not obviously something you would do in practice. You can't just assume this, but for the sake of simplicity in the class, we'll do this. So I'll change that to site class C, and we'll hit go here. And now you can see in the values that all of the values are populated. The most important ones for us are going to be SDS and SD1 down here, the values for the actual design spectrum. Now in the table below, there are additional values that you might need. Many of these values aren't typically needed, but we do need the seismic design category. The amplification factors FA and FV are used to obtain the values above, but we don't need them directly. You might be interested in the peak ground acceleration, the long period transition, and a number of other values that typically don't make it into the more simple designs, but they're here in case you need them. So let's come back up to the top here and compare this with the other tool, ATC hazards. ATC hazards, you'll notice, has a number of different hazards: wind, snow, tornado, and seismic. We'll still be focusing on seismic, and we'll search by coordinate. So here, once again, we need to zoom in on our site. And so I can come here and again roughly select with a click the location of our site, and you can see that it populates the latitude and longitude. Once that's done, I hit search, and I need to populate the same information. We'll use ASCE 716, risk category 2, site class. As I said before, in the class we'll assume site class C, although that's not a typical decision. We'll assume we have the geotechnical report that allows us to justify it. So here, once again, we see exactly the same information. We have the same information because it's pulling from the same database, so nothing in the underlying information changes, only the presentation changes. So we have the values for the MCE spectrum on bedrock at the site, and then for the design spectrum. What I like about the AT hazard site is it gives us on the right hand side the response spectrum, so it gives us more of a graphical representation that you might find useful. But once again, in the table below it gives us all these additional values, most of which aren't needed, but certainly we need the seismic design category to go forward with the design loads. We can compare the two, so let's look at the design spectrum values. SDS is 1.608. On the other tool, SDS is 1.607. Here, SD1 is 0.674. Here it's 0.673. any difference is attributable to the values of latitude and longitude, which we can see are slightly different because we clicked on slightly different locations. Obviously, this has no practical ramification in our design. So with this video, we've seen how to use these two seismic design tools to obtain our spectrum, our design spectrum for the site.